Here's a question. You're handed a number, say 123. Can you flip its digits to get 321? Sounds easy, but there's a catch. You're stuck with 32-bit integers. No bigger storage allowed. Let's set it up. Input is the integer 123. We want to return 321. Negatives keep their sign. Minus 123 becomes minus 321. And the trap. If the flipped number doesn't fit in 32 bits, we return 0. That bound matters. Okay, try the obvious thing. Turn the number into a string. Reverse the string. Turn it back into a number. It works on small inputs, but pause. The problem says we can't use 64-bit storage. Strings sidestep that, sure. And there's a deeper issue. We built the whole reversed number first, then checked if it fits. By then it's too late. We turned the input into a string, then back into a number, just to ask one question. Feels wasteful. What if we never built the whole number at all? What if we handled one digit at a time? Think about long addition in school. You don't add giant numbers all at once. You go column by column. Same trick here. Peel the last digit off the input. Stick it onto the back of our growing answer. Repeat. 2 operations do all the work. Modulo 10 gives us the last digit. Integer divide by 10 drops it. And to grow the answer, multiply it by 10 and add the new digit. That shifts everything left by one place. Now the overflow check. You might think to do it after building. Don't. Check before you multiply. If the current answer is already past the limit divided by 10, multiplying by 10 will blow past 32 bits. Bail out. Let's trace it. X is 123. Result starts at 0. Sign is positive. First pass. Last digit of 123 is 3. Drop it from X. Now X is 12. Check overflow first. Result is 0, well under the limit. Safe to grow. Grow the result. 0 times 10 plus 3 is 3. Result is now 3. Second pass. Last digit of 12 is 2. X drops to 1. Overflow check passes. Grow the result. 3 times 10 plus 2. Result is 32. Third pass. Last digit of 1 is 1. X drops to 0. Loop ends after this step. Last grow. 32 times 10 plus 1. Result is 321. Multiply by the sign and we're done. Notice what changed. We never built the full reversed number first. Each digit was handled in its own step. And the overflow check happened before the dangerous multiply, every single pass. No 64-bit storage needed. We touch each digit once. The number has about log 10 of x digits, so the time and memory grow with that. Okay, same logic, now in Python. Set up the bounds, remember the sign, and copy the value we will chew through. Now peel digits off the right one at a time and rebuild left to right, until the input is exhausted. Reapply the sign, then bounds check. If the result lands outside the 32-bit range, the problem says return 0. Otherwise hand back the reversed number. And that's the pattern. One column at a time, check before you grow. You'll see this trick again with linked list math.